Good evening, everyone. As we all know, climate change is a big problem because the Earth is getting warmer every year. The global population is also growing, so eventually we will need more food to feed everyone. This is a major problem in the plant world because at these higher temperatures, many plants grow poorly, so they produce less food. One of the reasons for this is because photosynthesis is a temperature-sensitive process. But how does photosynthesis really work? That's the focus of my research. Specifically, I want to understand more about the machinery involved in photosynthesis. One of the molecules that I work on is known as rubisco. And in photosynthesis, rubisco is responsible for changing carbon dioxide into sugars. And without rubisco, a plant would simply not survive. But rubisco does not work alone. This is where one of the other molecules that I work on comes in, known as rubisco activase, or RCA for short, which was appropriately named because its function is to activate rubisco. Now, RCA exists in two forms, known as alpha and beta. The beta form is always present. However, the alpha form is typically only present when the plant is stressed, and that includes being at these higher temperatures. Now, let's picture this system as a kitchen or a bakery. And in this kitchen, rubisco would be our mixer, combining all of our essential ingredients together to make some sort of batter. And RCA would be our kitchen assistant, with RCA alpha and beta being assistants A and B. Assistant B is always present in our kitchen to help make sure that our mixer is turned on at the appropriate times. But picture this, things are heating up. Our kitchen is on fire. Now, Assistant B is still there, but they're not great at managing this kind of stress. This is where Assistant A comes in. Assistant A is cool under stress and able to help manage our mixer even if our kitchen is on fire. Through our research, we learned how important RCA beta is for plants to survive, because without it, rubisco will not turn on, so our plants will not be able to perform photosynthesis. Also, we learned that RCA alpha is really important for helping plants manage these higher temperatures. And having this understanding of how plants function is really important in the future so we can help develop plant varieties that are able to survive and thrive at these higher temperatures so we can continue to feed the world. Thank you. Are there any questions? Yes. In the back behind you.
What happens if you take assistant A out of the plant? What happens to the plant? Does it survive fire or not?
So what we're working on right now shows us that without Assistant A, our plants can still survive at these higher temperatures. They just don't do as well. So they're not able to have the same levels of photosynthesis as plants that do have RCA alpha with them. So they tend to be slightly shorter, less productive, you could say.
A on all the time.
Yeah, that's a great question, actually. That's one of our future directions in a sense. So Assistant A actually isn't present in as much of a capacity, so there's not as much of it around. And with our plants, we also know that Assistant A is not able to completely replace Assistant B. So without Assistant B present at all, our plant does not activate rubisco, so it performs very little to no photosynthesis.
I wonder how much temperature increase can the plant tolerate?
Yeah, that's a good question. We actually haven't tested the limits of how hot our plant can be put in. When we put our plants under heat stress, we put them at 40 degrees Celsius, which is pretty hot. So I don't know how much that is in Fahrenheit for those of us that know temperatures in Fahrenheit. Yeah. But we usually compare 25 degrees Celsius versus 40 degrees Celsius.